Topic 8, superposition. This is a topic that builds upon the ideas developed in topic 7, waves. Now this term superposition, it sounds sort of quite complex, but it's really not as difficult as the term might sound. We have something called the principle of superposition. And what I want you to do in a moment is to have a look at page 110 in your dictionary and to have a look at the statement of this principle of superposition and then to write it down in your notes. But before we do that, let's have a look at a little animation that illustrates what this principle of superposition is about. Here we've got two pulses, somewhat artificially. One is a square-shaped pulse or a rectangular-shaped pulse, and the other one is semicircular. And those two pulses pass through each other. Now, what this is at present is showing the individual pulses, but it's not showing you the sum. It's not showing you what happens when these two pulses interact. Now, for some reason, that has stopped because I've circled it. I think if we just do that, we can keep it going. So if I click on sum here, this thing up the top here now, this sort of shape up through here, that shape there shows the superposition, the adding together of the two individual pulses to get the overall shape. So we just get rid of that. We can see it continuing to work. So they add together as they pass through each other. And you notice then after they've passed through each other, they really have been unaffected. So it's a temporary effect here whereby the two pulses add together to give an overall shape of a sort of like a single pulse, you could argue. That's one example. Let's have a look at another couple of different possibilities just in terms of this animation. Let's try an ellipse and a triangle. So we're talking about the superposition of these two pulses, the adding together of their individual displacements. Let's try two triangles. It's interesting to note that as those two triangles superpose or add together, we actually get a rectangular shaped pulse just temporarily as they're passing through each other. Just flicking over to a different animation, it's interesting just to see what happens if two sine-shaped things come together. Looks a bit complex. So you've got two sine-shaped things passing along, and we end up with, let's just have a look. Let's just keep it going a little bit longer. Okay, at that very instant, this top part here and this bottom part here are lined up, and so what do you end up with? You end up with the thing flat. And so instantaneously, you get the two things, the word we sometimes use, we talk about cancellation. We get the two pulses momentarily cancelling each other out, just at that instant only. Just continuing it on. See if we can stop it at a different point. At that point there, what we've got is we've got the displacement, let's say here, we've got the displacement due to this pulse, and nothing more. But over here, say at that position, we've got the displacement due to that purple pulse, plus we've got the displacement due to this pulse up through here. And so we add the two displacements together and we end up with a displacement up the top there. I'll just leave that animation going just for a moment longer, just so you can observe it a little bit more. Just takes a little bit just to get your head around what's actually happening there. Okay, moving back to our whiteboard stuff. All right, so page 110 then, look up the principle of superposition. I'll read it out for now, but as I say, you need to actually look at it. All right, so it states that when two waves meet at a point, the resultant displacement is equal to the vector sum of the individual displacements. So you take the displacement due to each of the two waves, you add them together, and that gives you the overall displacement of the final resultant waveform. A couple of points to note, and I want you to write these in your notes underneath the principal superposition. It's a fairly obvious statement, but at the same time should be made. The waves must be of the same type. So you can't talk about the superposition of a sound wave and a light wave. It just is a nonsense to say that. So they must be of the same type. And if it turns out that they are transverse waves, then we've talked about polarization. You couldn't have a horizontally polarized wave interfering, or superposing with a vertically polarized wave. So they must have the same plane of polarization or same direction of polarization, or else be unpolarized if superposition is to take place. So I keep wanting to say the word interference. We'll get to that term in a moment. Okay, so here's just a few examples of some pulses then. If we look at this first example on the left here, then this one, we've got two pulses, this pulse up the top and a second pulse lined up with it, and then they superpose, they add together to produce this pulse down here. And I hope that you can just slowly work your way through how that would come about. We've got, for this first bit here, just that square, so we end up with just that square there. And then for the second bit, we've got the square due to the top pulse and the square due to the bottom pulse, so we end up with something that's two squares high. And then the third bit, we've just got the square due to the bottom pulse, so we just get that. So overall, we end up with that shape there, represented by that bottom pulse. Second example, this one here. This time you've got a pulse that's up one way and then a pulse that's down below the line instead. And so if we look at the bits there, initially, one square, one square. Here in the next stage, a little bit like what we saw with those two sine waves, we've got a square above, a square below, so we get nothing at that instant, at that position, and then square below, square below. And then a couple more, and I'll leave you just to look through these last two and to think them through. But we're adding this time a triangular pulse to a rectangular pulse and getting some overall waveform. So in figuring out what this waveform down the bottom here looks like, we are using the principle of superposition. We're taking the displacement due to the first pulse, we could call it y1. We're taking the displacement due to the second pulse, let's call it y2. And we're getting what we could call y total, y1 plus y2. The overall displacement is the sum, or it says the algebraic sum, no, the vector sum, I should say, sorry, the vector sum of the two individual displacements. Vector because we are taking direction into account, above or below the line. Okay, I should just say that the previous example there I would like you to print off, I'd say, and put into your notes. Here's another practice exercise for you to have a go at. We've got two sine shaped waves, one there, another one there, and I want you to add those two together to give the overall shape of the resultant waveform using this principle of superposition again. So what we need to do is just a couple of examples. You take that displacement there from the first waveform plus that displacement from the second, add them together, and you're going to get a displacement somewhere up there for that particular point there along the medium. Let's take that point there. We've got 2 squares high plus 4 squares high. Take the 2 squares, add it on, overall displacement would be up there. And so you could start to produce the overall shape of the wave like so, the resultant waveform. So that's another example just to put into your notes and to complete. Right, I kept wanting to say the term interference earlier on. Time now just to introduce that term. One of the things I would mention about this particular whole topic of superposition is that there is quite a bit of new language in the topic. Terms like superposition, like interference, and there'll be other terms that we introduce along the way. All right, so what is interference? I've given you here a basic definition. Here, a statement which you should be putting into your notes, an effect that occurs when two or more waves overlap to produce a new pattern. So if you think about the examples that we've looked at so far, we've seen pulses overlapping, and at the point of overlap, there is a new shape, a new pattern produced. And this pattern, shows up then in the fact that the displacement at different points change. And one more example here, just of superposition again, or effectively interference occurring when these two pulses superpose. A little bit like the animation showing the sine curves, you've got these two sine-shaped pulses, slightly different shape, but basically they are sort of roughly sinusoidal, moving towards each other. At the point they start to overlap here, we start to get some combined sort of effect occurring, and that combined effect continues to occur, and then finally the pulses have moved through each other so that the medium, in the end, where they were overlapping, the medium ends up being undisturbed again. All right, so that example I'd like you also just to print off and to put into your notes.